Hey guys, we are now going to go back to the first example in quadratic formula. It ends up being not as nice as the last examples I did in the first video, so I wanted to kind of skip this one first time. But now we're going to go back to it. And the first step we want to do is rewrite this in the standard form of a quadratic equation, which is in the form of ax squared plus bx plus c. Okay, so when we do that by actually bringing the 14 to the other side by adding 14, okay, and we're going to set that to be 0, and we're just going to solve for 0. To do that, our a value would be the 2, our b value would be negative 12, and our c value would be positive 14. So when we plug it into the formula, we'd have negative 12, like that. Okay, and then we're going to take the negative 12 and square it, minus 4 times our a is 2, and our c is 14, all divided by 2 times 2, 2a. And we simplify the result. Negative 12 is positive 12, plus or minus the square root of 144 minus 4 times 2 times 14. So that's all divided by 4. Okay, I'm going to simplify a little bit more. I've got 144, and it's going to be minus 112. Okay, if I multiplied my 4 times 2 times my 14, and we divide by 4. So we end up with 12 plus or minus the square root of 32 divided by 4. Okay, if you notice what's underneath the radical sign, the discriminant, is actually not a perfect square. So we need to put that in simplest radical form. So how we do that, radical 32 can be represented by radical 16. The largest perfect square factor is 16, and then 2. So 16 times 2 is 32. The square root of 16 is 4. So the simplest radical form for radical 32 is 4 radical 2. So that means when I branch off, I'm actually going to branch off as 12 divided by 4 plus 4 radical 2 divided by 4, and 12 divided by 4 minus 4 radical 2 divided by 4. Now 12 divided by 4 is 3, and here my 4's cancel out, so I'm left with 3 plus radical 2. And with this one, 12 divided by 4 is 3, so 3 minus radical 2. So my actual solution here would be x is equal to both 3 minus radical 2, okay, and 3 plus radical 2. Squeeze that in there. Okay, so we already did 14 and 15. I want you to try to do 16 and 17 on your own, and then come back and we'll look at the answers. Okay, so pause the video here and then come back and we'll compare. All right, so welcome back. We've got our 2, negative 7, and then we've got a 6 for our a, b, and c. This would become 7 plus or minus the square root of 7 squared, which is 49, minus 4 times a times c. Okay, and that's all going to be divided by 2 times 2. We simplify. This is 7 plus or minus the square root of 49 minus 48 divided by 4. 7 plus or minus, okay, so this is going to become 7 plus or minus the square root of 1 divided by 4. Now the square root of 1 would be 7 plus 1 divided by 4, which is 8/4, which gives me 2, or 7 minus 1, okay, divided by 4, which gives me 6/4, which is 3/2. So the solution here would be 3/2 and 2. All right. Number 17, we identify the a is 2, b is 9, c is negative 5. All right, this would become negative 9 plus or minus the square root of 9 squared minus 4 times 2 times negative 5. All right, divided by 2 times 2. So we end up with negative 9 plus or minus the square root of 81 plus 40 divided by 2. I would divide by 4, sorry. And that would be negative 9 plus or minus the square root of 121 divided by 4. Okay, we branch out. This is negative 9 plus 11, because 11 square root of 121 is 11, divided by 4, which gives us 2/4, or 1/2. Or we have negative 9 minus 11 divided by 4. That would give us negative 24, which is negative 5. So our solution here would be x is equal to negative 5 and 1/2. Okay. All right, the next type we're going to learn is actually solving quadratic equations using square roots. So if the quadratic equation doesn't have a middle term, meaning if you have something like x squared plus 14 equals 0, you notice there's no middle term. There's no x term. So an x term would be like x squared plus 3x minus 12 equals 0. So if we just have something to the second power and a constant, we can just solve for x. And we do that just by using the golden rule of algebra. In this case, we're trying to get x by itself, so x squared is equal to 4. And then the inverse operation of squaring something is the square root. Okay, so we're left with x is equal to, the square root of 4 is 2, and it's also negative 2, because negative 2 times negative 2 is 4. So we write this as plus or minus 2. So we can write the set as negative 2 and positive 2. Okay. If we take x squared here, we bring 18 to the other side, and we take the square root of both sides, we end up with x is just equal to 0. So this is an example. If what's under the radical here is actually just the number 0, we're just going to have we'll just have one solution. And what that means is if you graph it, it's actually going to just touch the x-axis just at one point. So it's just going to have one x-intercept. Okay, so the answer would be x is equal to 0 there. Okay, and then number 20, in the case of number 20, we've got x squared is going to be equal to negative 7 when we bring the 12 to the other side. And when we take the square root of a negative number, you're going to find on your calculator you're going to get an error. Okay, so the answer is actually no solution. And that's because we can't take the square root of a negative number. The discriminant is 0. Is less than 0, then x squared equals d has no solution. And that's actually an example if we had a graph where it just actually never touched the x-axis. So it would never have an x-intercept. So pause the video and you can try the next 3. Okay, 9x squared is going to be equal to 49. If we divide by 9, we're going to get x squared is equal to 49 ninths. If we take the square root of both sides, that's equivalent to taking the square root of 49 and the square root of 9, so we end up with 7/3. So our solution is, and you can't forget, it's negative 7/3 and it's also positive 7/3. Because when we take the square root, it's actually the plus or minus, positive and negative. Number 22, if we divide by 2, we end up with x squared is going to be equal to 72. So 72, when we take the square root, it's not a perfect square, but we can represent 72 in simplest radical form. Okay, I can represent it as the largest perfect square factor would actually be 36. So 36 and 2, so we would have it as 6 radical 2, because the square root of 36 is 6. So in this case, the solution would actually be the negative 6 radical 2, and then the positive 6 radical 2. Okay, and the final problem here, if we divide both sides first by 6, we end up with x minus 4 squared is equal to 7. Now I'm going to take the square root of both sides. So I have x minus 4 is equal to radical 7. And again, it's plus or minus radical 7. And to get x by itself, we simply add 4 to both sides. So x is going to be equal to plus or minus radical 7 plus 4. So we can write that as, let me see, radical 7 plus 4, and then negative radical 7 plus 4. All right. All right, that's all for today. Bye-bye.